and you can't really see the GCF or anything. By the way, do you guys remember when we have full terms before, right? What kind of problems do we have with full terms? Anybody remember? We dealt with something with full. Yes. DNA, the onion DNA problem. Do you guys remember that one? Where we have a PST. Now, is this the one like that one? No. How do you know it's not that one? Because remember DNA, the onion DNA problem. How come it's not the onion DNA problem? Where you find a perfect square trinomial inside. How come it's not that one? How do you know? I know that it's not that one. Yeah.
Because the variables are different.
Yeah, the variables. You don't have anything square or anything like that, right? You don't have any perfect square. Do you see any perfect square trinomial within this? No. So you know. So if you have 4 terms, right? All the examples that we did today also are 4 terms. So guess what? We have to. Yes.
You have to group 2
Yeah, let's group them by 2s, right? Does that make sense? By the way, which 2 terms would you like to group? First 2, last 2, first and the last, 2 middle one. Which one? How do you want? Stefan? First 2 and the last 2, right? How come I don't want to group the 2ab and -9c? That would be a bad idea. Why not? Why would that be a bad idea? Yeah.
Because they can't be productive.
There is no GCF within those 2 terms. Does that make sense? But then the first 2 terms have a GCF, don't they? What about the last 2 terms? So yeah, so I think that's a good idea. Does that make sense? So how do you group them? You just put the parentheses around them, right? But do you think it's a good idea to make everything to addition first? Why is that safer? By changing everything to addition. Remember, grouping is, what property am I using here, guys? Associative property of addition. So do you think it's a good idea to change everything to addition first? Because there are cases if you just blindly put the parentheses, especially when there are a lot of negatives, you may make things wrong, right? You could get this one. So I think it's a good idea to change everything to addition because associative property, you don't have one for subtractions, do you? Right, Eddie? Does that make sense? So look at the first 2 terms, Eddie. Now it becomes the same thing that we did before. Do you have any GCF in here? First 2 terms? 2. Are you sure? That's the only GCF? 2 and A. So let's factor out 2A. What about the last 2 terms? 3. Who could tell me what to write? How about Ali? When I factor out a 2A from the first 2 terms, I get
2a parentheses b minus c.
good.
And then plus 3 parentheses b minus 3c.
That's right. Now I change everything to addition, because I don't want to make a mistake when I use the associative property. Does that make sense? So do you see any GCF? Yeah, now it becomes the ones that we've seen before. Claire, what do I get as my answer? That's exactly right. Is this easy, guys? Hello? Yeah, so if it's not one of those perfect square trinomial, the DNA onion problem, you group them by 2s. By the way, is there another way to group? Does it have to be first and the last 2? It turns out, for this one, it doesn't matter if you group. Yeah. Anybody see it? Yeah. First and the third one, and then the second and the fourth one. It still works out same way. Okay, if it does work, it's going to be first and the last, because you want me to do that, or do you think we get the same answer if you do it that way, the other way? Yeah, it works the other way too. But if it works the other way, this way, the first and the last 2 will always work too. So anyway, you could do it this way. You could group the first and the third, and then the second and fourth. Still works out. Okay. Same difference. And let's see if we get the same answer. Any question? Hello? Are we good? May I give you the last one then? Nice example? Alright. Now, this is a kind of a review though, because this is a reviewing the DNA problem. So let me show you. And let me show you how different that looks, okay? Even though it has 4 terms, right? Let me show you how this is different. So this one, you don't want to group them by 2s. Why not? Why don't I just group the first 2 and the last 2? Don't I get a difference of square for the first one, and the last 2 I have a GCF? Yeah. Yeah, this is, not only that, does it help you though? Couldn't I just group them by 2s and factor the first 2 as a difference of square and the last 2 as a GCF? No, because if you do that, would you find any kind of common factor? No, you wouldn't. Okay, so that won't work. Even if you group them by twos. But we learned this one. Remember, this was the DNA problem. Now, is it the first three terms then that are PST or the last three terms? How do you know it's the last three, not the first three? Raise your hand. Yes. Yeah, the last three, the variables, you could see that you have z. Look at this one, 4zy, right? If I were to pick first three, right, it's not going to be the PST. So who can tell me what to write this as? 4x squared minus what? In parentheses, don't I get this? Isn't this your PST? Perfect square trinomial? Right? By the way, why is this one minus and then here's one plus? Yeah.
Because two negatives have each other.
Yeah, you got a negative out here. When you put parentheses around here, right, you got to make sure you write the opposite of it, right? When you group them by with negative. So, let's fractal that PST. Remember we did it. This is not grouping by twos, is it? It's DNA. So let's, how many ways are there to get 4y squared, guys? There are two ways, right? Do you want me to try 1y and 4y first or 2y and 2y first? 2y and 2y. Would you not agree? Which one do I need for the... How many ways are there to get z squared? That's an easy one. One, which is z and z. But do I need... I need negative 4yz. So is it going to be negative z or positive z? I have to have negative middle terms. So I have to have both of them negative. Isn't that right? Hello? If you don't believe me, let's multiply it out. Don't we get all four checks? I mean, three checks. 2y times 2y, you get 4y squared. Z times z, you get z squared. 2yz times 2yz, negative, both of them. Don't I get negative 4 yz? Hello? Okay, so I'm done right here, right? When I do this. I get 4x squared minus, parentheses, 2y minus z squared. This is a review, right? We did this one before. Isn't it? Am I not done? Why is this called DNA onion problem? Am I done here, right here? Have I factored this? No. So what do I do? Eric?
You have to do.
Yeah, what is this now? We have is. Yes, sir. Difference of squares. Isn't this something squared minus something else squared? What's your a this time, class? Is it 4x? Is your a 4x? No, it's 2x, isn't it? Isn't it difference of square? 2x squared minus 2y minus z? What's your b? 2y minus z. Who could tell me what to write? It's going to be something plus something times something minus something else, right? What's your a? Class? What's your b? Somebody tell me what to write. Isn't that become a plus b times a minus b? So, who could tell me? Quickly? I'm running out of time here. Yes?
2x minus 2y plus z.
Yes.
2x plus 2y minus.
That's exactly right. Don't I get some a plus b? There's your a and b, right? Times a minus b? Hello? You see that? Let's simplify this bit. Don't I get this then? 2x plus 2y minus z times 2x minus 2y plus z? Yes? Why is it plus z right here? Because you got to distribute this. Negative 1. Right? Don't mess this up at the very end. So why is this called DNA problem, by the way? Anybody see why I call this a DNA problem? Has anybody figured this out yet? No? No one has figured out why I call it a DNA problem. Remember, DNA gives, you could tell the biological mother and father. Look at this middle term. This 4yz tells your mother, which is your y, right? And your father, which is your z. Does that make sense? I don't know. If you don't like that, that's okay. Are we good?